All right, so here's what we're going to cover today. We're going to do section 1.7, linear inequalities in one variable. And we're going to talk about these four ideas here. We're first going to do interval notation, and then we'll talk about linear inequalities, and then compound inequalities and absolute value inequalities. And all three of these should be review. Interval notation may not be review, but it's actually not that bad. So hopefully today will be a light day for you guys. Okay, so let's just jump into it. Let's talk about interval notation. So like the name implies, it is ways of notating intervals. So let me go ahead and write this. Okay, so let's just do an example here. If we're doing an interval, like one way we've seen them before is on a number line. So let's say that I want the numbers between 4 and 10. And I don't want to include the 4, but I do want to include the 10, and we shade in between. So this is stuff we've seen before. And you've probably seen how to write this as an inequality. Sometimes it gets a little tricky, but it's not that bad. The way I think about it is I want to actually, I'm talking about the numbers between 4 and 10. So when I write it as an inequality, I physically put the variable in between 4 and 10. And then since 4 is less than 10, I put less than symbols, and I want to include the 10. So this all says the same thing. Now, another way I can do this is through what's called interval notation. And so interval notation, what you do is you just list the endpoints. So my endpoints are 4 and 10, so I list them, put a comma in between, and always start with a smaller number. And then the way that I want to show that don't include the 4, but we do include the 10 in the interval, is the 4 gets the rounded bracket and the 10 gets the square bracket. So the parenthesis means don't include, but the bracket means include. In fact, sometimes you'll actually see this notation used on the number line. So if I just start off with this, so it looks very much like above, but instead of doing the open and closed circle, sometimes you'll actually see the bracket and the parenthesis. And just be careful that you actually open up in the direction of the shading, but all four of these things mean the same exact thing. So let's try another one just so you can see this. We're going to do two more real quick just so you can see some different things that show up. What happens if we have an interval like this? Well, as an inequality, it's not too bad because we want to shade. We're talking about all the numbers that are less than or equal to 3, and so we kind of just said it. It's x is less than or equal to 3. But wait a minute. I thought we said with interval notation, you put the two endpoints. So what happens when there's only one endpoint? Well, there's a right endpoint, but there seems to be no left endpoint. But think about where the numbers are going to in this direction. They're heading toward negative infinity, and so that's actually what we write for our left endpoint. We write a negative infinity and a 3. We do want to include the 3, but you can actually never reach negative infinity. So if your interval includes infinity or negative infinity, you can never actually reach there, so they get parentheses. And then if we think about the other way to do this on the number line, then using that notation, you just do this. You don't do anything at the infinity. So there's that. So one last thing that I want to bring up is what happens when there's more than one interval. So what happens when you have, let's do 4, 10, 20, I don't know, just making these numbers up. Let's include the 4, but not the 10, and we'll include the 20. And how about we shade here and here? So what is this going to look like? Well, when you have more than one interval shaded, and you're going to do it as inequalities, you're just going to need to do, it's like two separate problems in one. So the first interval is the numbers between 4 and 10. So I'm going to put x in between 4 and 10. I want to include the 4, but not the 10. And then the other interval is x is greater than or equal to 20. But we need to combine these intervals somehow, so we put the word or. And think about it, you got to put the word or. I want a number that's here or here. You can't put the word and, because you can't be here and here. There is no number between 4 and 10 and greater than 20. So you have to have the word or. And then interval notation, same kind of idea. You do both intervals separately. So the first interval, we want to include the 4, but not the 10. And our left endpoint is 20. Our right endpoint is infinity, but we can't include the infinity. And then in interval notation, instead of the word or, we use this symbol. And it's a union symbol, but it's like the word or. And then also, likewise, if we were going to shade on the number line using that, we want to include the 4. We don't want to include the 10. We do want to include the 20. And notice the bracket and parenthesis, they're opening up in the direction of the shading. So there's interval notation in a nutshell. Not too bad. Okay, so let's look now at solving inequalities. Just going to do a really basic example just to remind you. Let's say we were going to do let's do 3x minus 7 is greater than 12. So the nice thing is, when you're solving these, it's just like solving an equation. So you add 7 onto both sides, you divide by 3, and there's your answer. And just pay attention to the directions. If the directions don't say to write your answer in interval notation, or they don't say to write it on a number line, you can leave your answer like that. If you want to try this as interval notation, we want to be greater than 19 thirds. So starting at 19 thirds, we head towards infinity. And then that would be the answer right there. Okay. Just don't forget, if you ever have to multiply both sides or divide both sides by a negative, you flip the inequality. But that's it. Okay, so let's go to compound inequalities now. Let's just look at some examples there. So let's say we wanted to do 2 is less than or equal to 2x plus 3 over 7 is less than 5. Let's say we wanted to solve that. So we just have 3 parts now. This part, this part, this part. But we're going to solve it just like a regular old equation. So whatever we do to one side, we do to the other. But now we're talking about 3 parts. So if I want to look at isolating the x, I would have to first multiply by 7 to cancel this out. So that means all 3 parts multiply by 7. So I have 14 is less than or equal to 2x plus 3 is less than 35. And then the next step to get the x by itself is subtract 3, but I just do it from all 3 parts. So 11 is less than or equal to 2x is less than 32. And then finally, to get the x by itself, divide by 2. So 11 halves is less than or equal to x is less than 16. And voila, there's the answer. Now, one thing that I want to make clear when you're doing this notation, when you have it combined into one, looking for my laser. So when you have it combined into one thing like this, this implies and. So 11 halves is less than or equal to x is less than 16 implies that x is greater than or equal to 11 halves and x is less than 16. Whenever you have an and, you can always combine it into one compound inequality like this. This is actually considered a compound inequality too, this statement altogether. Compound inequality just means more than one inequality. So when you have it combined like this, you can always separate them if you need to, and you put a word and. Now, be careful about the direction for the inequalities. So like between the 11 halves and the x, the alligator is eating the x. So when I wrote it this way and put the x first, I had to make sure that I was flipping the inequality, so it's still eating the x. So x is greater than 11 halves, and x is less than 16. The way I want you to write your answer is the way I have it boxed. So this is the way you should write your answer to be fully simplified. In fact, I'll take off if you leave it like this. But sometimes it's nice to be able to think about it this way. And so I just wanted to point that out, that this implies the word and. Okay, if we just do one more compound inequality, all the fun stuff happens with the absolute values. Let's say that I had something like 3x plus 2 is greater than 5, or 2x minus 1 is less than negative 1/2, less than or equal to negative 1/2. So a couple things I want to point out here before we solve it. Number one is I have a word or. If you have the word or, there's no way to condense this down like we could have with and. If you have and, you condense it down like this. But if you have or, you just leave it. It's two separate inequalities. And we solve them like two separate inequalities. So on the left inequality, we're going to subtract 2 and divide by 3. And I'm still never dividing by a negative, so I don't have to worry about flipping the inequality. Over on the right-hand inequality, I add 1 onto both sides and divide by 2. And I get this answer. Now, your final answer, like if I ask you, and you should always box your answer, your final answer is this. It's all one answer. If I ask you to box your answer and you do, let's say that you wrote this, and you box this, and you box this, I am going to take off. The or is part of it, and it's all one answer. So do not write it that way. Your final answer is like this. It is all one thing. We are saying that x is greater than 1 or x is less than or equal to 0. All right, let's try one more of these guys, and then we'll move on to absolute values. So I'm going to give you guys one to try on your own, and do the old pause the video kind of thing. So what if we have 4x plus 2 is greater than 7, or 3 minus x is less than, I don't know, how about 5? So you guys try this one, and we'll see what we get. So pause the video right now, try it on your own, and then we'll do the answer together. All right, so let's see. Hopefully you guys already tried this on your own, so I'm going to quickly do it. Subtract 2 from both sides, divide by 4. Over here, I'm going to subtract 3 from both sides, divide by negative 1. Finally, I'm dividing by a negative, so I'm going to flip the inequality and get this, and so I have my answer. Or do I? If you boxed this, you're on the right track, but you are not done. Why not? So try to, if you're not sure why, pause the video and try to think about why not. But here is why not. Think about a number line. So here's negative 2, here's 5/4. I want to be greater than 5/4. So I'm going to just put it up here, greater than 5/4, and greater than 2. Actually, I should say or greater than 2. These shadings overlap. So let's think about it. We kind of have 3 intervals on this number line. We have an interval over here on the left, we have one in the middle, and we have one on the right. The interval on the left, did it make this one or this inequality true? And the answer is no, nothing got shaded. The one in the middle, Does it make this inequality or this inequality true? And the answer is yes, it made this one. So we're actually going to include that in our answer. And if we go to the last interval, this interval right here, this actually makes both of them true. So does it make the first one or the second inequality true? The answer is yes, it does. In fact, the 5/4 also made this true. 5/4 is not greater than 5/4, so it didn't make the first inequality true. But it did make this one. 5/4 is greater than -2. So we're actually going to shade that. We just won't shade the 2. So always think about your final answer. And in this case, both of those combine to this. This is the most condensed one, and we should write that as our answer. If we think about the one above, maybe we need to go back and change our answer for above. So we have 0, we have 1. We want to shade less than or equal to 0. We want to shade greater than 1. Nothing overlapped there, so we're okay. We need to include this interval. We need to include this interval. We need to include both of them. Here they overlapped though, so we just wanted the greatest interval basically, because that's or. All right, so that's it for that. Let's take a look at absolute values now. Okay, so let's first just think about absolute value is distance. So when we talk about the absolute value of a number, so for instance, the absolute value of -5 is 5. So when we're just talking about a single number, that's the distance from 0. So this means the distance from 0. But a lot of times in math, you're actually going to see something like this. You'll see something like x minus 3. So we have to have a minus sign for what I'm about to do, because we're talking about the difference. Subtraction means difference. So we want to know what the difference is between x and 3. But if we think about a number line, then the difference between x and 3 is going to be a distance of 3. And, or the distance between x and 3, I should say. Sorry about that. And then absolute value is just going to make it always positive, because distance always has to be positive. So when we have something like this, now we're talking a different kind of distance. Let me go ahead and put a number line on and just so you can see. So what if I had something like this? Actually, let me say the distance, finish up the sentence. The distance from 3. Or I guess it's a phrase. Sorry, English teachers. Okay, so what if I have something like this? What if I have the distance from 3 is less than 4. So let's think about what that means on a number line. So the distance from 3 is less than 4. That's one way you can think about this. Because remember that the absolute value can mean distance. When you have a subtraction problem, now we're talking about the distance between those two things. So let's put this on a number line. So the distance from 3 is less than 4. I'm going to start with 3 in the middle, and I want to go, sorry about the dots, pay no attention to the dots, and focus on my little tick marks here. So the distance from 3 is, it's supposed to be 4. Oh, I need a bigger number line. Hold on one second. Well, that's the wrong color. Okay. All right, let's try this again. So the distance from 3 is less than 4. So starting from 3, I can go 1, 1, 2, 3, 4 units to the right. And I don't know why it's making a straight line all of a sudden. Or I can go 1, 2, 3, 4 units to the left. 1, 2, 3, 4 units to the right. Ah, there we go. So where did we wind up? Well, if we start at 3 and go 4, 5, 6, 7, so we're at 7. Or if we go backwards, 2, 1, 0, -1. So all these numbers in between, and we don't have an equal to, so I can't be equal to, I can't have a distance equal to 4. But every number in between here, the distance from 3 is less than 4. If I take a look at this number right here, this distance from 3 is less than 4, because this is a unit of 4. From 3 to 7 is 4 units. So if I'm anywhere in here, I'm less than 4 units away from 3. Same thing here. If I'm over on this side, anywhere in the shaded region, I'm less than 4 units away from 3. So another way of writing that absolute value is I could say that -1 is less than x is less than 7. So this all means the same thing. Okay, so where am I going with this? Well, let's see. What if I had the same kind of problem, but instead of a less than, I had a greater than? Okay, so now what are we talking about? Now we're talking about the distance from 3 is greater than 4. So if I have a number line again, how about we make use of those dots? This time the distance from 3 has to be greater than 4. So starting at 3, I go 1, 2, 3, 4 units. So I can be over here. Now everything over here is more than 4 units away from 3. And then likewise, I can go to the left, 1, 2, 3, 4, and wind up right here. And everything in this direction also has a distance that's greater than 4 away from 3. So anything here is more than 4 units away from 3, or anything over here is also 4 units away from 3. So how am I going to write that? Well, this is still a -1 and a 7, but this time I want to be less than -1 or greater than 7. And so that's always going to happen. When you're dealing with absolute values, if you're talking about a distance within a number, a distance that's less than a number, you end up shading in the middle. You shade in between, so you actually have an and kind of problem. Remember how above I said that whenever you have an inequality that can be written like this, there's actually an implied and. Whenever you have an absolute value is greater than a number, though, now you're talking about the distance going beyond this many units. We want to be greater than that many units, so you end up shading on either side, so it creates an or kind of problem. So the bottom line, because now we're going to take these two ideas and put them into actually solving inequalities without having to do this whole number line. Once your absolute value is isolated, if it's a less than symbol, think less than. It's going to be an and problem. If it's a greater than symbol, you're going to think greater, and it's an or problem. So you're going to think less than, and this is greater. A less than symbol is and, a greater than symbol is or. Less than, greater. That's your short way of doing it. But this whole thing explains why a less than symbol is and a greater than symbol is or. Okay, so now we're just going to do a few examples and we'll be done. I got 4 absolute value problems we're going to do. So let's do our first example. How about the absolute value of 3x minus 7 is greater than or equal to 4? So when you're solving these, the first thing you want to do is isolate the absolute value. Make sure the absolute value, is the only thing on the side of the inequality. In fact, you want to make sure it's on the left of the inequality. So this one's all set up for us. So then we're going to actually create 2 different inequalities, just like we have above. This is a greater than sign, so this is greater. So it's an or problem. We're going to make it 2 separate inequalities with an or. We're going to do 3x minus 7 is greater than or equal to 4. So that's basically getting the idea of this distance is greater than 4 units in the positive direction. But we can also say that 3x minus 7 is less than or equal to negative 4. If we go in the opposite direction, there's a negative, but remember every time you have you flip the inequality, you're going to flip the sign. Or sorry, when you flip the sign, you flip the inequality. And then we go ahead and solve them. So add 7 onto both sides, divided by 3. And over here we add 7 onto both sides and divide by 3. And then there we go. So the bottom line is you're going to create a compound inequality. If it's a greater than symbol, you're going to make a compound inequality with or. Don't change what's in the absolute value, but you have the 4 positive or the 4 negative. And when you flip the sign, flip the inequality. And that's how you solve an absolute value inequality. So let's try another one. Let's try this. Let's try the absolute value of 3x minus 8 minus 5 is less than, I don't know, how about 20? Okay, so remember what I said you had to do first, that you have to isolate the absolute value. And right now we have this minus 5, so I got to move it over to the other side. So I'm going to add 5 onto both sides. At this point, I am not creating a compound inequality. I'm just adding 5, so notice I'm keeping the absolute value symbols. I'm not splitting it up. People try to do too many steps at once, and a lot of times they end up having mathematically invalid notation. So we're not splitting it up. Now at this point, think about, what do we got? We got a less than. And remember, you have to wait until the absolute value is isolated before you look at the symbol. Because again, in isolating the absolute value, we may end up having to multiply or divide by a negative, so this may flip. So wait until the absolute value is by itself before you look at the symbol. It's a less than, so it's an and problem. So now we're going to create an and. Now you have your choice. Remember, and problems can always be written like this without actually using the word and. And that's probably the easiest way of setting it up. But if you want to create, if you actually want to split it into 2 separate inequalities and put the word and in between and combine them at the end, that's totally fine. But I think it's easier to just do it now. So I'm going to do a negative 25 on one side and the positive 25 on the other side. And it may not seem like I flipped the inequality, but I really did. It's just things are on different sides. Here on this side, the inequality is eating the 5. The alligator is eating the 25. But on this side, the alligator is not eating the negative 25. So the symbol really is flipped in relation to the negative and positive 25. But anyway, now I solve it like I was solving the problems above. I'm going to add 8 onto all 3 parts now. So negative 17 is less than or equal to 3x is less than or equal to 33. Divide by 3, so we get negative 17 thirds is less than or equal to x is less than or equal to 11. And you're done. Da, da, da. So, I can't fit both problems. So there you go, there's that problem. Okay, so I'm going to give you something to try on your own. I want you to try this problem. In fact, we'll just do one of them, one at a time. So try this one. Try the absolute value of 4 minus x minus 5 is less than or equal to 10. So let's see what happens. You guys try it on your own, and then we'll do it together. All right, so let's do it. Have to isolate the absolute value, so I'm going to add 5 onto both sides. Now it is a less than symbol, so I'm going to make an and problem out of it. So I'm going to do negative 15 is less than or equal to 4 minus x is less than or equal to 15. We're going to subtract 4 from both sides. And then we divide by a negative 1, but I am dividing by a negative 1, so I do need to flip the inequalities. And I didn't really stress this, but it's pretty standard when you're doing a compound inequality, an and one. Start with a smaller number. So negative 11 is smaller than 19. So I'm actually going to flip everything and write my final answer this way. So there we go. Okay, one more problem, and this will be the end. You guys try this one on your own. Try 4 minus the absolute value of x plus 3 is less than 10. Okay, so pause the video, try that, and we'll see what we get. All right, so let's see. I'm going to isolate the absolute value, so I'm going to subtract 4 from both sides. And I get negative absolute value of x plus 3 is less than 6. Now I have to divide by a negative. So I am going to reverse the inequality and have this. Now if you were thinking it's a greater than sign, so we're going to do x plus 3 is greater than negative 6, or x plus 3 is less than positive 6. Remember when you flip the sign, you flip the inequality? If you were thinking this, I see where you were coming from, but you're wrong. Why? Let's see. Look back here. Think about this for a second. You can stop right here. It's a negative. The absolute value is either going to be 0 or positive. No matter what number you put in for x, once you take the absolute value, you're going to get a 0 or a positive number here. Isn't a 0 or a positive number always greater than negative 6? So don't do anything. Just write the answer. All real numbers. And be done with it. By the way, just some notation for all real numbers. Totally fine to write the words out like that. Mathematically, there is a symbol that looks like this. It's just an R with an extra line drawn in it. In fact, when you see it typed, it's more of a fancy R. Sometimes when you see it typed, you'll see it like this with extra line. It's kind of like, we've got, if you think of fonts when you're typing, there's Times Roman, which is a little fancier because it's got the things on the ends. But then there's Arial, which is a very simple, plain writing. This is kind of like the simple, plain text. The other one I can't even write by hand, but it looks kind of like a Gothic R, when you do the Gothic style writing. But anyway, when you see a fancy R in a math textbook, it's talking about all real numbers. If you're going to do it with interval notation, it's all real numbers. Your left endpoint is negative infinity and your right endpoint is positive infinity. So that's interval notation. And we usually don't, for all real numbers, we usually don't do inequalities. I know CPM would do this. And it's so awkward, I think, when you're dealing with alligator notation, the inequality, to use infinities. It's rarely done. So I'm going to erase this. Ugh. Much better this way. So there you go. One quick note, by the way. And I guess I'll do sort of an example, but it's going to be super quick. If you're solving an absolute value, you get something like this. On this problem, we got a greater than a negative. Absolute value is greater than a negative, and an absolute value is always greater than a negative, so we say all real numbers. If you had something like this problem here, an absolute value is less than a negative, an absolute value can never be less than a negative, so no solution. And you can just stop right there. All right, there you go. There's your notes in a nutshell. I was going to say notes in a nutshell, but that wouldn't be right. Notes in a note. I can't say it. Anyway, there's section 1.7. Have fun with your homework. Bye.